Hello students, welcome back to my channel. Let us start a new sum of 2023 WBJEE exam. So the problem is, let alpha beta be the roots of the equation ax square plus bx plus c equal to 0, where a, b, c are real numbers and obviously a must be non-zero, and Sn equal to alpha to the power n plus beta to the power n. And this determinant value is equal to k into a plus b plus c whole square by a to the power 4. Now we have to find the value of k. 4 options are given. We have to choose the correct option. Now to solve the sum, we need the basic requirements, that is, first one is properties of determinant and the second requirement is quadratic equation. We have to know about this. So first, the properties of determinant, that is determinant of AB, where A and B are two matrices. So determinant of AB will be determinant of A into determinant of B, and determinant of A transpose will be determinant of A. So we have to use these two properties to solve this sum. Also, this equation, that is ax square plus bx plus c, where a non-zero, this is called the quadratic equation, we know. And if alpha beta be two roots of this equation, then sum of two roots is equal to minus b by a, and the product of two roots will be c by a. So this basic requirement we need to know to solve this sum. Now come to this sum. So here see, it is given that Sn equal to alpha to the power n plus beta to the power n, and in determinant 1 plus s1, 1 plus s2, 1 plus s3, 1 plus s4. These are given. So first we find s1. So for n equal to 1, we get this value, that is alpha 1 plus beta to the power 1. That means this is the sum of two roots minus b by n. Similarly, by putting n equal to 2, 3 and 4, we are getting these corresponding values of s2, s3, s4 respectively. After that, now coming to the original determinant. Now in this determinant, just we have put the values of s1, s2, s3 and s4, normal, just we put the values. Now just look at this form of the matrices. Here this diagonal is called what? This diagonal is called the principal diagonal or main diagonal, right? So here we can see that these two positions, these are same, right? That means having the same element. So this is a symmetric matrix. Now if we further notice that we can express these matrix by the product of these two matrices. Just see by cross checking. First row into first column will be 3, so 3 is here. First row into second column, that will be 1 plus alpha plus beta. First row and the third column, that is 1 plus alpha square plus beta square. Second row first column 1 plus alpha plus beta. Second row second column 1 plus alpha square plus beta square. Second row third column 1 plus alpha cube plus beta cube, and so on. In this way we can multiply these two matrices, and we see that after multiplication we are getting these matrix. Next, now if we consider this left side matrix as the capital A matrix, then the A transpose, AT means what? A transpose. A transpose will be the right side matrix. Just see how to find A transpose. That is, the first row will be in first column, second row will be in second column, and third row will be in third column. That means we have to write the row element column wise. So we get A transpose. Now, so this is determinant of A transpose, and this is determinant, no sorry, the first one is A. So the first one is determinant of A and the second one is determinant of A transpose. Now as our given property, that is determinant of A equal to determinant of A transpose, So determinant of A whole square, right? Now this matrix is capital A suppose, and this matrix is capital B suppose. That is, we are putting A transpose, it is B. So determinant of A into determinant of B will be determinant of AB, that is this determinant, by property 1. Okay, that means the original determinant value will be equal to the product of these two determinant values. Now we are finding the determinant of A, then after the we will square it, then we get the original determinant value. So let's find the determinant of A. Now see, here we can see that the first row, all the elements of first row is 1, and each of the element of second row is also 1. So this is the common trick, that if we find any one row or any one column having all the elements equal to 1 or the same element, then we will make it 1 0 0. So first we making this. How to make this? See, the first entry will be 1. That means this first column will be fixed. Now second entry, that is A1 2 position, first row second column position, this element 0, how it will be? By C2 minus C1. So our C2 dash, that is new column 2, will be C2 minus C1, and similarly C3 dash will be C3 minus C1. Now note that when we are subtracting, also we can do, if you can say that if we do C3 minus C2, so it is also 1 minus 1, so we will get 0. But no, don't do that. When we keep first column as fixed, then we have to subtract C1 from C2 and C1 from C3. If you do that C3 minus C2, it will be wrong. The correct result you will not get. Next, so by C2 minus C1 we will get alpha minus 1, alpha square minus 1, and similarly beta minus 1, beta square minus 1. Then just by using the determinant formula, so for 1 into this into this, but before that if we take common, see, from the column 2 we can take common alpha minus 1, and from column 3 we can take common beta minus 1. So the remaining terms are 1, and here alpha square minus 1, so a square minus b square formula, that will be alpha minus 1, alpha plus 1, alpha minus 1 already taken common, so alpha plus 1, the remaining term. Similarly here also beta plus 1. So this is the simplified form. Then this is alpha minus 1 and beta minus 1. Now for 1, just we crosswise multiply it, so beta plus 1 minus alpha minus 1, 1 cancel, that means we get alpha minus 1, beta minus 1 and beta minus alpha. Okay, so this is the value of determinant of A. Now we can simplify it by product this first two term, so it will be alpha beta minus alpha minus beta. So if we take common minus, then we get alpha plus beta, and minus 1 will be plus 1, beta minus alpha. Now we can put the sum of two roots value, that is minus b by a, and the product of two roots value, that is c by a. So it will be c by a minus b by a, minus minus it will be plus b by a, plus 1 beta minus alpha. So After simplifying, we are get C plus B plus A and beta minus alpha. Now here it was determinant of A square. So by squaring we get determinant of A whole square. A plus B plus C whole square by A square beta minus alpha whole square. So A plus B plus C whole square by A square, and it can be written as beta plus alpha whole square minus 4 alpha beta. Then we put the value again, that is alpha plus beta is minus b by a, so it will be b square by a square, and it is c by a. Okay, that means a plus b plus c whole square by a to the power 4 into b square minus 4ac. Now see the problem, that is this original determinant value, that will be this, and also the determinant value is given k into this. That means what is the value of k? The value of k will be only this term, b square minus 4ac. Okay, so option A is the correct option. Thank you everyone.